This is Eitan Weinstein.
And I'm Naor Menninger, and you're listening to Two Nice Jewish Boys.
In collaboration with Australian Jewish News, check them out at ajn.timesofisrael.com. Also in collaboration with Arutz Sheva, israelnationalnews.com. Since Delta is on the rise and we might all be put back in our cages in a few weeks' time, we thought it would be a great idea to revisit our old friend COVID. But this time from a different angle, the poop angle. Dr. Yair Lewis is part of the Health Ministry's National Lab for Environmental Virology, led by Dr. Itai Bar-Or, which is testing sewage across Israel to help pinpoint high-risk coronavirus infection areas. Dr. Lewis is also the VP Medical at Navina, a medical AI startup. He earned his MD from the Hebrew University and is board certified in internal medicine. Yair also holds a PhD in molecular biology from the Technion. We are super excited to be joined by Dr. Yair Lewis today to talk about COVID, about poop, and about maybe a few other things in the medical field. So, how are you? Thanks so much for joining us.
Hi, I'm great. Hi, guys. It's lovely to be here. Just a small correction. I'm not part of the Central Virology Lab.
Ah, okay.
But I did work with them and try help them out.
Okay, so you're working with them. So we'll get into that a little bit.
Yeah.
We'll get into that in a second. Before we get started, guys, just if you're listening to this podcast, you probably have some interest in Israel. Okay, so Masa Israel Journey is the marketplace for long-term opportunities in Israel. You can explore your career path, you can live out your passions, and you can make a positive impact on the world. It really is a great organization, a great opportunity. I myself was on a Masa program. During the pandemic, Masa also created opportunities to study and work remotely from Israel. So while you're in Israel, you can be remote. So, Delta, it doesn't have to be a concern. You can come here. You can stay remote from wherever you'll be living and work and study. You don't need to know Hebrew. You don't need to pause your life, but you do get funding if you apply. So check them out, masaisrael.org/two nice Jewish boys, masaisrael.org, TWO, nice Jewish boys. Check them out.
So, where do we begin? What wrong turn did you make in your life that you ended up in the Ashkelon or I don't know which city sewage system? Deep diving.
So that's actually an excellent question that I've asked myself a few times this year, especially since some people were calling me and I was speaking with them and I introduced myself as hi, the Yair from it's Yair from the sewage, and that became my literal title, Yair from the sewage.
And you're saved in their phones, right?
Yes, and I'm pretty sure I'm saved as Yair Sewage in multiple people's phones. So that is a good question. So I think in Israel, and one of the great things in Israel is how everyone knows everyone. And I think people have talked about this a lot, this whole startup nation thing and all that. A lot of it has to do with the ability to basically within, 2 or 3 degrees of separation, you can probably reach a lot of the people in Israel. Either you went with them to the army or to school or to university or your neighbor knows them. And when this whole pandemic started in last March or even a bit before that, a lot of people found themselves doing things that they normally would not be like part of their day job. And I knew a friend who knew a friend. And I sort of had this idea pretty early on when we were thinking of maybe innovative ways when there was this whole thing, if you remember, with the swabs. There were not enough swabs. How are we going to test people? How are we going to locate the geographical spread of the virus?
Sent Mossad agents to rob swabs from
somewhere.
Yeah.
And I remember this thing about, when I was in medical school, I think, or maybe it was, no, it was, I was already in residency, in, I think 2012 or 13, all the children in Israel got a booster shot of the polio vaccine. If I recall correctly, I think that was the timeline. And I remember reading about that, and they detected it through sewage. So I was thinking, this sounds like a very interesting idea. Maybe we could do this for coronavirus. Maybe we could track its spread through the sewage, sort of pinpoint, the geographic distribution and find infection clusters. And then we would only have to test specific areas. We would have enough swabs, etc. And I thought, okay, so I wrote down a few things. I did some homework. I did some research about this. My background is in molecular biology, but obviously nothing to do with environmental biology. But I did see that in 2005, when the 2003 actually, I think, when the SARS epidemic was going on, there were some papers published later on that show that SARS can be detected through wastewater. And I was thinking, okay, so this is from the same family of viruses. Let's see what we can do here. And this network of Israelis knowing each other got me in touch with, I wrote it down in a paper, such as a proposal for the a Ministry of Health, and a friend of mine got me in contact with Dr. Itai Bar-Or. So Itai Bar-Or, he's a really key figure in all this. He's in charge of the environmental surveillance unit of the Central Virology Lab in Misrad Habriyut. And I spoke with him, and I sort of started introducing myself and telling my idea, and he was really excited. He said, listen, I've actually been trying to get this off the ground. I had thought of this, and we're trying to do this. I've been taking wastewater samples from Sheba and etc., and from places where we think it would be positive, and trying to test it to see if we can detect it. But at that point, the Ministry of Health was very preoccupied with more important stuff. This sounded like a crazy far out idea, and actually they were telling him, listen, we're not going to fund you, don't do it. And he was just one person working with a few other collaborators in the lab. And I said, okay, great. And I sort of got into, let's say, like a startup mentality where you like trying to do things really fast and cheap. And once again, this whole thing came into play where people know people. And within like a week, we sort of got this working group together with the Central Virology Lab, Itai Bar-Or, who was key to this, Professor Ariel Kushmaro from Ben Gurion University, together with his postdoc student, Dr. Karin Yaniv, and later on also Professor Eran Friedler from the Technion, and each one brought his own perspective. So Dr. Kushmaro, Professor Kushmaro was there. They are environmental biologists, and they know how to track microbes in the environment. But they had less experience with a specific technique of needed for extraction of COVID. And Eran Friedler from the Technion, he's an engineer who deals with the way sewage systems are built. So he brought in a lot of very important knowledge about how how we can utilize the structure of the of sewage systems and understand where we want.
Because it goes by neighborhood, streets.
Yeah. So
how is it actually done?
The sewage system is. I'm just going to say a word about sewage system. So the key point here is the sewage system is hierarchical. Okay. Mm-hmm. Sewage only flows one way. If it's flowing the wrong way, then something's wrong.
You're in trouble.
Yeah, exactly. It only flows one way. And because it's at least in Israel and most industrialized places, it's been built into place. It doesn't really change very often. And if it does, usually the local company will know about it. So you can get very detailed maps of how the system is built. And when you're sampling from a location, the technical term is, what the catchment area is. Okay, what population precisely you're now representing with a sample, because this manhole right here, this sewage or wastewater treatment plant, takes in all the sewage from such and such area. So how is it actually done? So that's a great question, and I'm going to go back to polio. So polio, because in the beginning, my first conversation with Itai, I thought, okay, great, I got to the guy who actually was involved with this polio thing, and that's it. I can, go back and leave this, and they probably have the infrastructure in place. But polio is very different. Polio is an enterovirus. If I get too technical at any point, just stop me. So polio is an enterovirus, which means that it lives in the intestines. It actually can infect people. The usual route of infection for polio is fecal oral, so it's called. So when polio is actually in the sewer, it's a live virus, as much as a virus can be live. That's a different question. So when you want to monitor polio, you need to take the wastewater, and you basically do something called a plaque assay, which is you take the sample, you put it on a plate with cells, and you check to see if the cells are infected with polio. That's how it's done. And the sampling was also pretty small scale. So I think it was 5 or 6 locations, and primarily in areas in the south where the previous sort of cluster came in through settlements in the Negev. And so for coronavirus, that was not going to work. Coronavirus is destroyed in the intestines. And it does not infect fecal orally, at least not commonly.
It's respiratory.
Exactly, it's a respiratory virus. And how does it even exist in way that was a big question. But that was why in the beginning the Ministry of Health was saying, listen, you're not going to be able to find this virus in wastewater. You're wasting time and money. Because it's an RNA virus, and RNA is an extremely sensitive and environmentally labile molecule. RNA gets
RNA
destroyed.
Virus?
Yeah.
Really? I didn't know that.
SARS beta coronaviruses are RNA viruses.
You knew the vaccine was
RNA.
RNA.
The vaccine is RNA, but I didn't know the virus.
The virus is an RNA virus. Yeah. So and incidentally, my PhD dealt with mRNA and cardiac myocytes, and I spent several years working with RNA, and every time you work with RNA, and any molecular biologist knows this, it's like you need to say a special prayer, clear out everything, all the other stuff you've got in your lab, clean everything insanely, because you're extremely concerned about the RNA getting degraded. And that's
why? Can you explain that a little
bit? So it has a very interesting evolutionary reason for that, which is, as far as I know, at least that's how I explain it to myself, because basically RNA is what? RNA is a template for creating protein, right? Mm-hmm. When a virus enters a cell, how does it hijack the cell? A virus does not have ribosomes. A virus basically takes its genomic material, injects it into a cell, and uses the host cell's machinery to create its proteins, and which is
reproduce
the virus. Exactly. So cells have evolved to immediately degrade any not artificial, but external RNAs coming into the cell.
So basically, it's at high risk of just disappearing in the sewage.
That's right, being degraded, disappearing, and that's
disappearing as far as like detective measures go.
Yes, but also disappearing in a sense that RNA, that molecule, is now broken down into ribonucleic acids. It's not.
You won't recognize it.
It's not RNA anymore, which is, incidentally, that's one of the. It was a challenge. The big challenge of gene therapy was getting RNA into cells, and we actually worked at this in my lab a bit about developing, trying to get cardiac myocytes to sort of regenerate after a heart attack by inserting RNA for protein that would encode for proteins that would allow them to reproduce, because normally cardiac cells don't reproduce, right? If there's been a heart attack, some part of the heart is damaged, and that's it, there's a scar there. But the main challenge was getting that RNA into the cell, and that ties in nicely with mRNA vaccines, because they basically found a way to get the RNA into the cell without being degraded. With their Pfizer using BioNTech, they developed something called a lipid nanoparticle, which is a small particle made of sort of a lipid molecules, those are fat molecules.
That protects.
So is that
protects the mRNA and allows
and its journey to the destination.
and allows it to enter the cell and be.
It's pretty cool.
And was that the main challenge of producing the vaccine?
I'm not an immunologist or vaccinologist, but the main challenge, I would guess, was getting RNA to be expressed into cells. I just know from my, sort of small perspective on what we were trying to do in my laboratory, the main challenge of any therapy which includes inserting RNA into cell, and because that has huge potential for many diseases, where the problem is either a defective protein or you're trying to get a cell to do something it doesn't normally do, like a cardiac myocyte, which is regenerate or repair itself.
But facing you guys, the main challenge was the fact that you might take a sample of sewage and there's even if the entire building or the entire neighborhood is infected, you're not going to find any traces of COVID.
Yeah, so let's get back, because I sort of sidetracked you guys a bit, so sorry about that. But
no, it's really interesting.
So the idea of COVID monitoring through wastewater is basically to detect the RNA in the wastewater, the COVID RNA. And I'll just go back to what I said earlier. That's very different from just checking for polio, because polio, you're actually you're culturing the polio virus out of the wastewater. And here, the virus will not be cultured through the wastewater. You're trying to detect its remnants, its fragments. So first of all, we weren't even sure that this is possible. So we read those papers about SARS. So it sounded technically possible. And then the first experiments were done by Itai Barot. He took samples from Sheba Hospital, and actually from, if I recall correctly, from Dan Panorama Hotel, which I think was, so to speak, a Malone Corona.
Right, it was a Corona hotel where people who got infected and they didn't want them to stay with their families and infect them, they had the option to go on the state's funding to a hotel.
Was it an option? No, I think it was an offer they could not refuse, if I recall correctly, at that stage.
No, if you had like an option to self-isolate in your home in a different, you could have stayed, but many people preferred, not to risk their families. Yeah,
so it's So he assumed correctly that if we're going to try that, let's get some wastewater which would be highly enriched with SARS-CoV-2. Mm-hmm. And he told me, listen, I'll be able to take this, and then the process is basically you take the raw sewage, and then it's a couple of steps, and I'm not going to get too technical, but basically you need to clear out the solid materials out of the sewage, and then you need an
gross. Just feel like that has to be said. Gross.
You know, I'm an internal medicine physician, so it would take a lot to gross me out. That I would say maybe 3-4 on the gross scale out of 10.
So what? Okay, now we have to ask, what's 9-10?
You know, usually when the poop is in the wastewater, it's removed from a person, so it's much less gross or intimate, or so. Okay. But it usually starts out within the person. So those situations.
I didn't know that, but I think we got the picture.
Good. So then you take the fluid, and you need to extract the RNA out of the fluid. You need to enrich the RNA with genomic material, extract RNA, and then take that RNA. Once you've got the RNA sample, it goes downstream into the same real-time PCR or quantitative PCR, is where you, just like you would do for a normal swab test, where you would try to use primers to identify the specific genomic material of SARS-CoV-2.
But how come there were traces?
Well, because this virus is protected by it has sort of like an envelope.
Right, an oily, I think.
That's right. Yeah. So that protects the RNA from being totally degraded. And that's why it is possible to identify it.
It's amazing because it just goes to show how well built, how well developed this virus is. I think, in a very primal way.
Nature is 100% undefeated, and this is just one example for it. It would always find a way to evolve into the way that would be most advantageous for survival.
Evolve or be engineered.
Yeah, Jeff Goldblum was right.
Yeah.
Jeff Goldblum was right in Jurassic Park, I guess. And he said, nature always wins.
Is that from Jurassic Park?
Yeah,
I don't remember that.
Yeah.
Okay,
Yeah.
maybe I had it in my head. I just remember.
It's from Jeff Goldblum. Goldberg.
Goldblum. Yeah.
He came up with it.
Anyway, okay. So you tested the waters from the hotel. What did you
so
see?
that was like sort of a proof of concept, and we showed that it was actually positive. We got back positive results.
But how is it? I'm actually interested. How is it done? Like, do you have to go into you lift the sewer cap, you go down, you actually scoop it?
So
is there?
Yeah. So I'll give you a bit of more insight into this. This pull you behind the curtain, so to speak. So first of all, it's a question of sampling. So when you're just taking a sample, okay, which is you're opening up the manhole and you're putting in your bucket and just pulling out water, or putting in your pump and pumping out water for, let's say, a minute, 2, 5, 10, you're getting a spot estimate. And that's not very useful, okay, because the flow is continuous. So if you want to really measure the level of any material in sewage, you'd have to take a continuous sample. And let me tell you, and there's actually been academic research done on this, part of it, by the way, by Aaron Fiedler. So the amount of biological material in sewage is not equal throughout the day. So most people go to the bathroom either in the morning or at night. So it's sort of like a bimodal curve. So you need to capture all of that if you want to make sure that you're actually sampling the entire population. So the way to do that is with continuous sampling. So what you do is you put in a pump, an automated pump, which is sort of triggered to a program to take whichever volume of sample you've decided. Yeah, like take 200 milliliters every hour or something like that. Then you end up with this huge container that has like anywhere between 6 and 12 liters of fluid. And you take that to the lab. And when you get to the lab, that's when you do the whole different steps of centrifugation, to get rid of the solids. And then another step that, there's different ways to do it. Ultrafiltration is one step. Dialysis is another step. Basically, you're trying to draw out the genomic biological material out of all the other chemicals and stuff. And there's all sorts of technical, sort of molecular, biological, technical problems. There are inhibitors that would inhibit the real-time PCR from happening. You need to add all sorts of additive, but basically it's a series of centrifugations and other steps of adding materials to end up, at the end, you get like 50 milliliters of sample that's enriched for, or 20 milliliters or 10, depending on the protocol you did, from that huge 12 liters of that you started out with.
And that's what you test.
And that's what you put into the same exact pipeline as a regular swab test.
And what happened in the first time you did it?
I think the first sample Itai took was from Rambam, from Sheba Hospital. And he got a positive result. It was very interesting. I was very happy with that. Then we got together and we thought, okay, let's lay out this sort of experiment plan where we would prove that this thing is actually efficient. At that stage, we already got into discussions with higher ups in the Ministry of Health, and we got their authorization. We also, again, through different connections, we got a company called Kandu. It's an Israeli startup that do automatic waste monitoring basically for chemical pollution mostly. But they were really cooperative and excited, and they helped us out with putting in automated samplers at different areas, and that was the experiment done in Ashkelon last year. After which, I think that was already published in the papers and stuff. And there were all sorts of, discussion. We got the results, we analyzed them, And at some stage, we were able to actually show that, listen, we're getting results that are correlated with what we're seeing in terms of morbidity, okay, with caseloads in a specific area. And at that stage, it already was sort of, okay, Ministry of Health decided to give it some funding and add more people into it. And it's been going on like that since then. And there was this big thing right now where they've sort of ramped it up, and they authorized a bigger project to.
And there was an article that was published a few weeks ago.
An academic paper.
Yes.
The group, the group we work with, that we work with, you know, our group, we published a few papers led by mostly Professor Kushmara and Karin Yaniv from a lab, and Itai Baro. There was one actually, and it's another interesting discussion about how academic publishing has changed. It's the first paper was published and was still not peer reviewed. It's just published in medRxiv or bioRxiv. You know, it's it's a preprint server, but already I think has like 70 citations.
So it's important to find a match between the results that you get from the test from the sewage and the actual results in the field, because if they don't match up, then
I would divide it. No, I would divide it into two stages. So the experimental phase, which was basically where they were at until not too long, was we were trying to match it, and we did a whole series of experiments between October and December where we showed that there was really good correlation. Okay, we showed graphs where we did some data analysis, we ran some regressions, and we showed that the sewage level of COVID correlates really well with caseload in a specific area. So once you've proven that, and that was not just, we were not far from being the only group in the world doing this. So and there are groups who are much more far along the way than us. And in many countries, I would say between 5 and 10 countries already, there's an actual waste monitoring system already in action. And there have been many papers published on it that have shown this correlation. So this was not just our isolated finding of some crazy guys saying that this would correlate. It's been quite validated with different papers.
It's ingenious if you think about it, because you could have this waste monitoring be automated and simply, to a certain extent, and light up, a red light turns on when a neighborhood is at high risk, and then you can test those people,
right?
And that way you kind of bypass having to put the entire country through these very restrictive.
Moreover, the problem with knowing where COVID hits is that it takes time from the time you're infected to the time you show symptoms to the time you take a test. So
and another thing is that not all people show symptoms, and what has been repeatedly shown in different papers published is that wastewater monitoring has the potential to sort of give you the signal of a COVID spike before it becomes clinically apparent, before you get this bunch of people complaining about symptoms and being tested and blah, blah, blah. You could know that like 2 or 3 days before. There's actually another review paper published on this last week. And that's the potential. So, if we would have had this in place in Israel in March or April, we sort of could have anticipated what was coming in June. Because in May we would have started to see it's also sort of like a ground truth, okay? Because it doesn't have to be connected to the amount of testing done. So one of the questions now everybody's asking themselves that, like, what is the real what is the real chance of getting severe COVID, and they're looking at the numbers, and one of the thoughts on this is, okay, it looks like maybe it's a bit higher than we thought, but that is just because the denominator we're dividing by is lower because we're not testing enough, maybe. So maybe there's a bunch of asymptomatic individuals that we don't know about. Now, if you have sort of like a ground truth, like wastewater monitoring, you would just see a level, track it over time, and you would be able to actually know the actual level in the population.
But what is this? What is the saturation level that the population needs to reach in order? Is it? And I'm wondering if that saturation level is like if at that point it's too late, meaning it will already have been show up in other neighborhoods and spread.
Yeah. So I think saturation, it's like once you know about disease, it becomes maybe less important. Like right now, I don't know how important waste monitoring it maybe is right now, just to gauge the national spread and the levels. But the limit of detection is interesting. Like at what level would you first detect it? And what we had shown was between, if I recall correctly, depending on the place, between 20 and 50 people per 100,000, which is pretty good in my opinion.
What was that, like 0.5% or even less?
It's not a lot of people. It's pretty sensitive. Now there's a whole lot, and other people have shown maybe even less. It gets a bit technical, but it has to do also with where you're monitoring. Are you monitoring a sewage line, or are you monitoring sludge at a wastewater treatment plant?
But so if that's true, then if you're testing a building in Tel Aviv, in Florentine, like a 5-6 story building, you'd be able to detect if one person had it.
Yeah, that's right. But that, I don't think that is
nowhere to hide it.
Yeah. Well, you could go, to the rest
to the woods
in a different, So, you
the proverbial Pope does it. Yeah,
exactly. You could hide theoretically, but I do not think that's really a viable, or a use case for this. I think the most logical or the use case, the most valuable use case is to monitor like a population size of 50,000, 100,000, get the signal, and then, I have maybe a rise of cases in this area. I can now use other pathways to detect where it is spread.
So I have a really good one. Okay, it's about what we talked about, poop property rights. Okay. So I want to touch on this, and we joked about it before the show, but I really wonder about, like, we spoke about how we might talk about the ethics of AI in medicine maybe later on. But yeah, let's talk about poop ethics and basically, are you concerned with where this might lead?
Are you asking like about cleaning the toilet?
Yeah. Should you leave the seat up or down, or no? Okay. Are you concerned with where this might lead in the sense that now maybe it's not viable to put a test in every building, but maybe in 100 years you'll have a test in every building, and the second your apartment is detected, you'll be locked down, or I don't know what. You know what I mean?
Even if you eat unhealthy.
Or
they'll detect it in
like,
China.
Do people have a right over what's being tested?
That's a good question, but I would take it to even a more realistic question is, in the States, in some areas they test for opiate levels in wastewater. Because opiates do not exist in the environment. Opiate it's a small chemical that can be easily detected in wastewater. And basically, they can know where people were using opiates, were using drugs, were using heroin. It's being used in some prisons in the United States where they're getting, and that can be a good thing, because you can say, okay, we know we have a problem of drugs coming into the prison, but and I think, and this is true for every technology, there's always the dystopic view of that technology, and that's always a possibility. So am I concerned? I'm concerned about technology being used for nefarious reasons for any technology. So this goes for this technology as well.
So before we move on to your other endeavors, I gotta ask, so what's the weirdest, like, did you dive in the sewage?
Yeah. So no one actually dives into the sewage, but I would say
no one.
That's what they told me when they did. But when they gave
Florentine, I'll show you a few people who probably.
Okay, sorry to hear that. I'm from the suburbs. I'm from Mrna. Don't tell me all this stuff. So the weirdest I would say was at the height, like, of the first lockdown and I think if we try to remember, people are actually, I think, a bit scared or concerned, or people weren't really sure what was going on, and like it was a scary thing. and we went, and I remember I went with Itai, and I've got to mention Ehud Rinot, Dr. Ehud Rinot from Ben Gurion University, was a great collaborator on this project. He really helped me push it forward and organize it. His PhD was also on poop, so he analyzed microbiome.
He's a poop professor.
Yeah, I think he's on his way to becoming a professor. So I remember we went together and we went to sample the main wastewater line of Bnei Brak, which, if you're trying to think back about, April 2020, that was like one huge corona. They were bringing the army in, they were doing, fencing off there and everyone was like, and I remember when we went to test the wastewater, we were actually wearing these suits, and because we were not even 100% sure that we would not get infected by tasting it, but by obviously not tasting it, but testing it. And I remember we took out this huge container with like 10 liters of sewage, and it's basically concentrated 1 days of sewage from Bnei Brak. And I was thinking, okay, this is just hot.
You could have dropped it in Iran and solved two problems in one.
I think that they had more corona than us at that point.
Okay.
So that was pretty strange. That point.
Wow, that's but you're wearing protective gear, or
Yeah, we were wearing like these suits. I think they were wearing suits. I was actually just wearing. I did not think it was infective at that point, but yeah, we were wearing masks, obviously, and gloves.
Okay.
Cool, very cool. So there's a future for this technology.
I think there is, and I think not only for COVID. I think like many things that have come out of the pandemic, I think some technologies that may have started out as COVID are going to find use cases for other stuff as well.
But
Cool.
I want to go back 1 second, and then we can maybe move on to the issue of ethics, because my question is it, do you think that it is, and this is kind of out of your field, but it's more of a political question, but do you feel that it is ethical to test people's waste without their consent, right?
So I think it depends on, and that would be debatable, what the catchment size would be. So, because, and let's take it to the extreme, if we're taking out a sample from the Shaftan, okay, Shaftan is the big wastewater treatment plant that takes the wastewater of, I think, 1 or 2 million people. I don't think anyone would claim that is unethical because you're pinpointing somebody. On the other hand, let's take it to the other extreme. A person lives by himself in a villa, and you test his wastewater coming out of his house. Obviously, that might sound problematic, and I would say it is problematic. So where does the border lie?
Hard to say.
It's hard to tell. As I said, I think we should probably focus on testing cities or areas about 50,000, 100,000 people. And to me, I do not feel that's an invasion.
The Chinese will probably take this technology and they put it in every apartment.
Just stick it to your butt.
They may have already done that.
Yeah. They actually did. There was an article about anal swabs in.
Is it real?
In China. There was a BBC article.
As I said, I come from internal medicine, so anal swabs are not something we do it for every patient who comes in to check.
Yeah, but you don't force them to do it.
No, we do not force them.
Yeah.
So on a very firm segue, AI.
It's hard to segue from that. It really is.
Yeah. But your startup, which is its name again is
Navina.
Navina. You do AI, medicine AI.
Yeah.
Medical AI.
Medical AI.
So tell us a little bit about that. You guys help care providers.
So what Navina does? Navina was founded by Renan and Shah, who came out of doing a big AI project in the military, and they decided they wanted to do it in medicine, which I think is commendable, because you've probably been reading the papers about NSO or all the cyber stuff, and some of it isn't nefarious, but it could have been much easier for them to go into that. They decided they want to do something useful to humanity, and again, as in everything in Israel, a mutual friend got me connected with them, so I came in as a doctor to the company. And what we do is we take a medical record and we generate a summary of the record automatically using AI, and putting out recommendations for the doctor for specific things he needs to look out for in the specific visit.
So what kind of things might surface, and how exactly, I mean, you can't maybe give away the algorithm, but how exactly would the AI even differentiate between what's important and what's not important?
Well, it has to do with the way the algorithms are trained, obviously, and we're doing it for family doctors. And I think that the best way to explain it, to sort of give an example, is perhaps you've been in a situation where you're going to see a doctor and you tell him, listen, I have abdominal pain or chest pain or I have a cough, and so he's listening to you, but then you say, okay, I had this thing 3 years ago, but then he's not listening to you anymore because he's probably turning away to his computer looking for it. And then you say, yeah, I had an ultrasound done, or I went to a gastroenterologist. His attention to you has now probably dropped to zero because he's looking for those exams to see what was done and try and understand it. And why does that happen? And as a doctor, I've been on the other side. That happens because you don't have time to be a data miner on the electronic medical record. You don't have time to collect that information before the visit. And what our system does is, instead of, and I had this thought many times as a doctor, I was spending too much time at the computer, not enough time listening to the patient. And I thought, wouldn't it be great if instead of me just going through different menus and looking for information, and which can take anywhere between 10, 15, 20 minutes, even for complex patients, if I can get a summary that would be
of the option of most probable, and
that's already the actual diagnostic step, but I'm just speaking about collecting the information and organizing it logically. And what a system does is it does it automatically, and then in between 30 and 60 seconds you can read everything you need to know about the patient and just devote your whole attention to him. Plus you're not missing anything that would have been perhaps missed because our system pops it up.
So what, you can write abdominal pain and then get all the relevant things that relate to the abdominal pain?
Yeah, so eventually, yes, that's what we're aiming for. That's what we're aiming for.
I have a guess at how the algorithm works. You can wink twice if I'm correct, but you had the algorithm watch all the seasons of House MD.
It's always an autoimmune disease.
It's lupus.
It's lupus. It's lupus.
That would have been a very simple algorithm. We don't need a startup. But you're asking about ethics of poop. So medical AI brings in interesting ethical questions.
How so?
Because first of all, who is responsible? Okay, so if a hospital is using an AI that's designed to detect some medical condition automatically, and then the AI fails and the patient dies, who's responsible? The doctor, because he did not detect the disease, or whoever implemented that AI system? Another thing is that, and this is a really big and real issue, is bias, okay, within AI systems. An AI can be trained, let's say, on a certain data set, can be trained on a data set of images taken only from white patients. And then it would fail on black patients. Why? Because it was trained to detect melanoma on white skin. But the patient sample they use, and these are real things. That's a really big issue. It could be trained, basically, what is AI or machine learning? It's basically pattern recognition and classification by the computer. So it could be trained to detect some medical condition, but basically it was using features that are sort of orthogonal to the condition, and it would fail on a different population. So it would identify, let's say, white people or people from higher socioeconomic status with that condition more often than it would detect other people from lower socioeconomic status.
But wouldn't these biases and these preconceived notions and all, I mean, that's what the human mind does, right?
That's right. And because humans are designing AI. But since
for now.
Yeah. Until we get Skynet. But so what a big thing, I think, is for everyone who's dealing with this designing AI, be to eliminate that. We're trying to use technology, and this harks back to what I said a few minutes earlier. I think technology always has the option of being nefarious or less useful for society, and humans will decide the way it will be used for. And these things aren't they do not have to happen that way. If you build your data set in a way that's balanced, then you would not have these biases.
So it's a really interesting issue. I know from my end that there's also, I mean, in computer vision, there's serious issues with black versus
That's
white.
right.
It's very hard to detect and recognize a black face as opposed to a white face, because the models are trained mostly on white, and also certain simple physical facts cause it. The fact that in the dark, for example, or if there's less light, then black reflects less light, and that's
It's not a
problematic.
PC thing to say, Eitan.
Yeah.
Yeah, but if the designer is aware of that, and
Maybe it can be
that's
designed around.
Designed around. Use a different sensor. Okay, use
Yeah.
maybe infrared to detect more or different wavelengths.
A very good
stuff like that.
algorithm. I can't help but think about Minority Report, because if you implemented this algorithm within Google phones or within Apple phones, so theoretically your doctor could know you have a problem before you even know it, because you just Google something that you're feeling or said it to your friend, and your doctor, the algorithm will calculate it and tell your doctor, listen, your patient has a problem, and he'll know even before you feel anything.
That ties in. I agree. That ties into to another point. I think medical AI is realizing that it should be used to augment doctors and not try to replace them at this point. And I think that that's to tie into what you're saying, it would suggest, and the end decision would be done by the doctor. He would take in all the information and decide. It would not be a black box deciding something about someone's future. And I think rightfully so, that's what sort of freaks people out and concerns them, and I would be too,
but
if that would be the case.
I can't help but think about the chess computers. When I was growing up, there was this. I remember I used to go to chess tournaments and play chess, and the greatest chess computer was Deep Blue.
Yeah, and it beat Garry Kasparov. Right?
Yes, but
moment.
Kasparov beat it originally, or beat the previous computer, and then eventually Deep Blue beat Kasparov. And now, I never even thought about this because I hadn't played chess for years, and I mean, I played, but just as for fun. And I looked now at the situation, and there are chess computers today that not a single human being on Earth can beat. Yeah. They're so far beyond our capability. Nobody can play them. I mean, they're just not even beatable. Yeah. So eventually, maybe it will reach that point where AI is.
Yeah, but I think at that point, a medicine would be able to transition back into, the more empathetic part, the being empathetic to the patient, caring for the patient. Okay, so you've got an AI just assisting you, maybe even making decisions for you. But I think and that ties into what you're talking about, what your company does. I think that human connection between doctor and patient can be strengthened by AI if taken to the right direction. So taking that stuff that, that maybe pattern recognition stuff that computers are good at, and allowing they're much better at that than humans, but allowing the human to do the thing that he is much better at least in the foreseeable future, which is empathy, which is care, which is understanding the patient, guiding him through that health journey. Yeah, that's the way I see the hopeful, future of AI
until they get better at empathizing, and then
I'm probably going to be dead by that.
So. We don't need to worry about it.
Thank you so much for coming. It was really really interesting.
Yeah, definitely. We could do a whole nother episode about AI and medicine.
Before we go, we are sponsored by Masa Israel. You're on social media, right?
I am
Twitter.
I am on Twitter. That was a big change for me this year.
Yeah. Oh, okay. So how can people find you?
Google Yair Lewis on Twitter, I guess.
Okay, it's another type of sewage you've been sampling.
It was an interesting experience.
Yeah. So guys, check out. I think you also tweet in English, right?
I do tweet mostly in
Yair
English.
Lewis on Twitter.
And if you're in the medical field, apparently Dr. Yair Lewis published 5 papers. You said this year.
I was a part of a team.
Part of.
Purposes,
So check those out.
We're sponsored by Masa. Check them out. MasaIsrael.com/2NiceJewishBoys. Thank you so much, Masa, for sponsoring this episode. Also, ערוץ 7.
Yes, israelnationalnews.com. Check them out. They also have a Facebook page, Aruch Seva, or their website, israelnationalnews.com. And, of course,
Australian Jewish News, ajn.timesofisrael.com. And show some love to our Australian brothers and sisters under
for
lockdown.
the Australian Jewish perspective. And guys, we do this on our free time. So if you want to help us out, go to 2njb.com/donate and help us out. Thank you so much. Really enjoyed it.
Thank you. It was lovely.
Bye guys.